Hi everyone, this is end term revision and this video will be regarding week 11 syllabus. Our first topic is Bernoulli Trial. So, it is a trial in which your outcome is either a success or a failure. In Bernoulli Trial, we usually denote success with a random variable 1 and failure with a random variable 0. So, if x is a Bernoulli random variable, it has only two possible values, 1 or 0, where again I repeat, 1 is success and 0 is failure. Now, in a Bernoulli trial, for example, you tossed a coin. So, you can either get a heads or a tail. So here, if you denote heads with success and tails with failure, you can say that this is a Bernoulli trial. Uh, Let me tell you guys that in a Bernoulli trial, it isn't necessary that probability of getting success is half and failure is half. It can vary accordingly. So, in some cases, like if you throw a dice, a fair dice, so a sample rather than sample space, a range would be R would be 1, 2, 3, 4, 5, and 6. So their relative probabilities would be 1 by 6, as I already told you guys that it is a fair dice. Now here's your Bernoulli trial. Your Bernoulli trial, let us suppose there's a Bernoulli trial that uh, you get a number greater than 3. So in a toss is greater than 3. So here your Bernoulli trial is success is 4, 5, and 6. On other hand, failure is 1, 2, and 3. But on other hand, if it was, let me use another pen. So if it was, uh, here you can see that success and uh, failure has 1 by 2 probability each. If your toss had exactly 6, so here your success would be 6, and all other tosses which you will get will be regarded as failure. So here your failure has a chances of 5 by 6 and 1 by 6 for success. So it can vary accordingly. Now let me give you some examples. Suppose and there's a manufacturing company. It produces, let us suppose, mobile phones. Okay, so a company produces smartphones, and uh, probability of getting defected piece is 0.15. Okay, it's a rather big number, but don't worry, for example it's fine. So let us suppose defected is a failure, so here your failure has a probability of 0.15, and success, which is let us suppose it said good looking smartphone. So this good looking smartphone has a success rate of 0.85. So here what I'm trying to say is that your success plus failure, probability of success plus probability of failure, sums up to 1. There is no other probability except these two, and to find the probability of success you will add up all the individual successful events, and to find the probability of failure you will add up individual probability of failure events, like I did dice in dice example. In this one, see, here it was there are 5 events and each had 1 by 6. Each elementary trial had a 1 by 6 probability, so 5 into 1 by 6 gives 5 by 6. So in this there are examples. You can see that in an experiment like voting experiment, suppose there's a candidate, we need to find the probability of candidate getting chosen. Suppose there's 2022 Indian poll, 100 people are chosen. So we need to find out if probability that Modi is chosen, probability of Modi being chosen. So suppose 28 people uh, out of 100 choose Modi, so this would be 28 by 100, or we can say 0.28 is the probability, and its complementary probability would be 0.72. We don't care how many candidates are there, nor we need to find it about nor we need to find those candidates. We can just straightforwardly say that 0.72 is the probability of not choosing Modi as a candidate. So in a Bernoulli random variable, as I already told you guys, it can either take 1 or 0, and usually we denote the probability of getting success with P and probability of getting uh, failure as 0, which is denoted by Q, and it can be said that Q equals to 1 minus P. As I already told you guys, probability of success plus probability of failure, which is P plus Q, is 1. Next is our expectation. So in a Bernoulli random variable, our expectation would be xi p of I, as there are only two values, I equals to 1 to 2, sorry, I equals to 0 to 1. So here we can say our expectation is 0 into q, which is 1 minus p, plus 1 into p, which sums up to p. So uh, we can say that our expected value or our mean would be equal to the probability of success. On other hand, to find the variance, what we can do is either subtract, like using a traditional way of finding variance, we can say actual value minus the old value. So you can do it by that way, or either you can use that v of x is e x square minus e of x whole square. To see the traditional way, or the it's something like this actually. V of x equals to uh, e of x minus xi. It is summation of this. So let us suppose there are n number of random variables, so I equals to 1 to n e of x. So we need to find this, we will get a variance accordingly. So using this method, our expectations remain the same. It is probability p. When we square this, our values will remain the same, and probability corresponding to it will remain the same. So e x square will be p minus p square, and we will get p into q as variance. We can write it like pq. Okay, so this is all about Bernoulli trials. Now here, this line, or you can say, if you need to find most uncertain probability, then whatever value is close to 0.5 would be your answer. The thing is that, suppose there's a coin tossing, heads and tails. So heads get a probability of 0.2 and tails has 0.8. Now you are asked that what is this. Now you can see that it is likely certain to get tails, or you can say that it is expected to get two heads in 10 tossings. So, or you can say that it is certain to get more tails than heads. But if the probability is close to 0.5, it is uncertain if we will get more tails or more heads, or what will be the majority outcome. So in that case, we can say higher the probability, or more it will be close to 0.5, more uncertain the trial would be. So our next topic is independent and identical distributed binomial trials. It is also called IID trials or IID Bernoulli trials. So in this, or you can say it is defined like a collection of random variables is IID if the random variables are independent and share common probability distribution. So you can understand it with examples. So here, see, uh, in a sack there are 60 balls, and in that sack there are 40 black and 20 red. So we need to select 3. When we will select first ball, uh, before selecting that, every ball had a probability of 1 by 60. But as soon as we selected first one, their probability shifted to 1 by 59. So we can see that the probability is not constant throughout the experiment. So we will say no, this is not an IID. On other hand, there is another case. Suppose that you consider an experiment of rolling a dice until 6 appears. So, here what you are doing is you are continuously performing an experiment without knowing what is the total number of trials you are performing. So here you do not know what are the n number of trials you are performing. It is uncertain. So you will say this is not an IID or independent Bernoulli trial. So for an independent Bernoulli trial, for an IID, there are two things that you must have. First is probability constant throughout the trial, and second is fixed number of trials. So you guys keep this in mind. Now let us do some questions. Suppose before that, let us know how to calculate an Bernoulli trial. Here, suppose you are performing an independent trials and x is the number of successes. So if you need to find the probability of I successes, you will use this formula. This formula is denoting, in this formula, this combinatrix part is denoting number of ways. So suppose there are 1, 2, let me use another pen. So suppose there are 1, 2, 3, 4 up to n number of trials. So we don't actually know if our first trial is successful, second is successful, third or fourth, or how many or which I. You just know that there are I success, but you don't know the pattern which is going throughout the total number of trials, whether it's success or failure. So let me give you a short example. Let us suppose n is 4. So the possible cases can be success, 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 and success. There can be total 8 possibilities, na? So another can be, let us shorten this. It would be total 16, I suppose. So let us suppose n is just 2. So success, success, or it can be either success and failure, failure and success, or both are failure. So here, if uh, it is supposed to be 2 and I is 1, you don't know which case is possible. So what you will do is to multiply, or to say 2c1. Your n is 2 and number of possible ways of selecting 1 is 2c1. So here it is similar. If you say that you need I number of successes, what you will do is number of ways of selecting I from n, nci, into now see here, if you get I number of successes, what you will do is multiply p I times this, total will be I times, into I was so